Hi everyone, welcome to my virtual classroom. So today we're going to learn about angles created by secants and tangents outside a circle. As you can see, according to this problem, you have two secants intersecting a circle at points BD and CE respectively, and both secants intersect at a point outside a circle at point A. What is measure of angle A? Okay, so if you look closely, what can you say about measure of angle DBE? Well, according to this, measure of angle, this one, DBE, is an inscribed angle, which is always half of its intercepted arc. So if arc DE is 110, then the measure of angle DBE has to be 55 degrees, okay? So if you look at measure of angle BEC, this one, what can you say about that angle? Well, that angle is also half of its intercepted arc, which is half of 20 degrees. So therefore, this angle must be 10 degrees. So how would you find the measure of angle A at this point? Well, if you look closely, if you look at triangle ABE, the 55 degrees is the exterior angle of triangle ABE. And we know that the exterior angle of a triangle is always equal to the sum of its remote interior angles. So what we can say here is that 55 degrees is equal to, since that is the exterior angle of triangle ABE, is equal to the measure of angle A plus measure of angle BEA, okay? Okay, but we know that the measure of angle BEA, that one, is equal to 10 degrees. So we can actually erase this and just write plus 10 degrees. So therefore, measure of angle A is equal to 55 degrees minus 10 degrees, which is equal to 45 degrees. And that is basically the answer for the do now, okay? Okay. So that is it, 45 degrees. Okay, so if you look closely at 110 degrees and 20 degrees, we somehow want to come up with a conjecture that we can easily always calculate the angle created by two intersecting secants outside a circle. So let's look closely at this. Okay, so here we have a circle, okay? Okay, let me get a ruler now. There you go. So let me draw a secant here really quick. So here we have a secant. Okay, so now we have another secant here. Okay. So let me label the points as A, B, C, D, and E. So according to the do now, the measure of arc CE is 110 degrees, and the measure of arc BD is, what was it? Let me see, 20 degrees, okay? And we were able to figure out that the measure of angle A was 45 degrees, okay? So the question is, okay, instead of doing all this with the exterior angle and drawing another chord, is there another simple method that we can implement that allows us to easily and quickly find measure of angle A? So let me ask you a question. What is the relationship between 110 degrees, 20 degrees, and 45 degrees? If you want to pause the video at this point, you can do it and try to figure this out, okay? Okay, so let's reconvene here. So if you take 110 degrees, subtract 20 degrees, and divide it by 2, what do we get here? So here we get 90 degrees divided by 2 equal to 45 degrees, okay? Now we have a conjecture. Is it true that the angle created outside a circle from two intersecting secants, is it always true that it is always half the difference of their intersected chords or arcs? So what I'm trying to say is the following, and I'm trying to get a different color here. 1 second. There you go. So is it true that if you take this arc over here and this arc, is it always true that if you take the difference of those two arcs and divide it by 2, you always get this angle over here? Okay? That's what we're trying to explore today. So basically we're saying, okay, measure of angle A equal to measure of arc CE minus measure of arc BD divided by 2. And that's the biggest question for today. And that is a conjecture. Okay, so a conjecture means that we have an idea, we don't know if it's always true or not, and we want to test the idea and generalize it, okay? So what would you do to figure out if this is always true? Okay, we just have to generalize it somehow by deriving the formula with all the theorems and postulates that we know. Okay, so let me draw a circle now. Let's try to figure this out. So let's say we have a circle here. Let me draw the two secants. Okay, so here's the secant. Draw another secant here like that. And let me label the point as A, B, C, D, and E. Okay. So what's the first thing you would do here? Our goal is to figure out what is measure of angle A, correct? In terms of arc CE and BD. Okay, so the first thing we do is let's draw a chord that connects point B and E. Okay, so let's do that. Let's construct the chord here like that. We'll draw one in. So it's very similar to the do now. If you look at this angle over here, okay, what is that equal to? Well, measure of angle CBE is equal to 1/2 measure of arc CE, okay? So what's the reason for that? Why is it true? Well, according to what we have learned previously, the inscribed angle created by two chords in a circle is equal to 1/2 of its intercepted arc. Okay? So that is something that we already learned. Okay, so let me move it up there a little bit. Okay, I guess we can leave it like that. Okay, so what can we say about this angle? Similarly, measure of angle BEA or BED, it doesn't matter, that is equal to 1/2 of measure of arc BD, okay? And it's basically the same reason as above, okay? The inscribed angle created by two chords or two secants, it doesn't matter, is always 1/2 of the intercepted arc, okay? But we know that the measure of angle CBE is also the exterior angle of triangle ABE. So therefore, measure of angle CBE is equal to measure of angle A plus measure of angle BEA. Okay? What's the reason for that? Well, let me type this in. Here we can say the exterior angle of a triangle is equal to the sum of exterior angle of a triangle is equal to the sum of the remote interior angles. And that's basically the reason why we can write this, okay? Okay, what else can we do here? Well, we know that measure of angle CBE here, this one, let me highlight it, that the measure of angle CBE is equal to 1/2 of arc CE. So what we can do here is substitute. So by substitution, okay, we can write that 1/2 measure of arc CE is equal to measure of angle A plus, and by substitution, we can say that measure of angle BEA, this one, is equal to 1/2 measure of arc BD, okay? So let me substitute that, measure of 1/2 measure of arc BD, okay? Okay, so all we need to do is now solve for A. So measure of angle A is equal to 1/2 measure of arc CE minus 1/2 measure of arc BD, okay? Which simplifies to the following. Measure of arc A is equal to 1/2 in parentheses measure of arc CE minus measure of arc BD, okay? And that is basically the proof for our conjecture, okay? So it actually works, as you can see. So if you go back, that was our conjecture, okay, that it was half the difference between arc CE and BD, okay? And it actually works, as you can see. We proved it that it always works, okay? So here's your discussion now, or a thought, you know, something to think about, discussion or thought. Think about, obviously, it's hard to discuss when you're all home. Let's say that you have a circle, okay? And instead of drawing two secants, let me draw a tangent and a secant. Okay, so here's a tangent and a secant, okay? And let me label the points A, B, C, and D. Well, is it the same thing? Can we also say in this case that, you know, if you want to find the measure of angle A over here, this angle, is it also that angle A is equal to the difference between this arc and this arc? And the answer is yes, okay? I'm going to leave it up to you to try this out. So basically, all you need to do is just make a chord here like that, you know, and then you can obviously say, okay, that is half of measure of arc BD. This one, this angle, is half of arc BC. Maybe that's something for you to think about. Why is it half of measure of arc BC? Okay? And then another thing is this. What if you have a circle, okay, and now you have two tangents? Hold on, let me draw the tangents. There you go. 1 and 2. There's the other tangent here. Okay. Is it true that angle A, let me label this point, A, B, and C, is it true that the measure of angle A is equal to arc BC minus arc BC? Basically, the major minus the minor arc BC. And the answer is also yes, and you can prove it, okay? And that's something I'm going to leave up to you. You can also check in the textbook, but it actually always works, okay? So that actually leaves us with a theorem, okay? And that's actually the conclusion for today's lesson. Okay, so here's the theorem. There you go. I'm just gonna copy and paste it. The measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside a circle is equal to half the distance of the measures of the intercepted arc, okay? This is actually also known as power of a point. So let me write this here. Power of a point, okay? So that theorem is called the power of a point, but if you ever have to use it in a proof, I would write it out. Most likely you won't see something like this on a proof, but these types of theorems are used more for algebraic problems, as you're gonna find in the worksheet, okay? So at this point, I encourage you to go to my Schoology, okay? And you should be going to lesson 86. So go to lesson 86, there's a folder. You will be seeing your, the worksheet in there. Please work on it. I'll be posting the answers as well. And then I'll let you know about the homework assignment, okay? If you guys have any questions, please let me know. Please email me, okay? I'm more than willing to help you guys, so please let me know if you have any questions, okay? Other than that, I wish you a good day and be safe, everyone, okay? Bye-bye.